Linear objective function. Objective function means the function which is to be maximized or minimized is called the objective function. The common region determined by all the constraints including the non-negative constraints x and y greater than or equal to 0 of a linear programming problem is called the feasible region. Optimal value means maximum and minimum value of the objective function is called the optimal solution. Hello dear students, welcome to this session of Mathematics Revision class. I am Mr. Niranjan, Faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss regarding linear programming, the revision of linear programming. This is very simple chapter and very important chapter. So you may expect one 6 marks question and one 1 mark question from this chapter. Now, what is the weightage? One 1 mark question, and whereas one 6 marks question in part E, a sure question from this. Now, let us take a few definitions. So, what are the definitions you are going to expect for the examination? You may expect 1 mark one question from few definitions. A linear programming problem, LPP. A linear programming problem is one that concerned with finding the optimal value. So, a linear programming problem is one that concerned with finding the optimal value. Optimal value is nothing but finding the maximum and minimum value of the function of a linear function of several variables is called a linear programming problem. Finding the maximum or minimum value of a linear function is called a linear programming problem. A linear programming problem is one that is concerned with finding the optimal value, that is maximum or minimum value of a linear function of several variables. Now, linear objective function. Objective function means the function which is to be maximized or minimized is called the objective function. A linear function z is equal to ax plus by, where a and b are constant, which has to be maximized or minimized is called the linear objective function, where a and b are constants, variables are x and y are called as the decision variables. Okay. Here a and b are all constants, whereas x and y are called as the decision variables. Now, a function which is a function of the form z is equal to ax plus by is called a objective function. A function of the form z is equal to ax plus by, where a and b are constant, which has to be maximized or minimized is called as the objective function. Linear objective function, where a and b are constants, x and y are called as the decision variables. Now, feasible region, this is very important, you may expect this definition. The common region determined by all the constraints including non-negative constraints, that is x is greater than or equal to 0, y is greater than or equal to 0 of a LPP is called as the feasible region. The common region determined by all the constraints. The very important point is the common region. The common region determined by all the constraints including the non-negative constraints x and y greater than or equal to 0 of a linear programming problem is called the feasible region. What is the feasible solution? Feasible solution. Points within and on the boundary of the feasible region represents the feasible solution of the constraints. So, that is the points within and on the boundary. The points within and on the boundary of the feasible region or the feasible solution of the constraint is called as the feasible solution. Now, optimal solution. This is also an important definition. Any point in the feasible region that give the optimal value. Optimal value means maximum and minimum value of the objective function is called the optimal solution. Any point on the feasible region that will give the optimal value, that will give the maximum and minimum value of the objective function is called as the optimal solution. Now, then definition of constraints. The linear inequalities or equations or restrictions on the variables of a LPP are called the constraints. So, x is greater than or equal to 0, y is greater than or equal to 0 are called as the non-negative constraints. So, these are few definitions in this linear programming problem. So you may expect any one from this. So now let us take on to the problem. So there are different methods of solving a linear programming problem. So in your syllabus you are going to study regarding solution by graphical method. Now let us know how to solve a linear programming problem using graphical method. So you may expect this type of question for 6 months. Solve the following linear programming problem graphically. Maximize z is equal to 4x plus y subjected to constraints x plus y is less than or equal to 50, 3x plus y is less than or equal to 90, x is greater than or equal to 0 and y is greater than or equal to 0. Now let us convert these inequalities into equalities first. So the given equation x plus y is equal to 50, another equation 3x plus y is equal to 90. Convert the inequalities into equalities. Now just find out the points. So put x is equal to 0, very simple method. Put x is equal to 0, 0 plus y is equal to 50, y is equal to 50. Consider this as the first point, a is equal to 0 comma 50. Again put y is equal to 0. If you put y is equal to 0, x plus 0 is equal to 50, we will get x is equal to 50. The other point b is equal to 50 comma 0. So to get a line, to draw a line, minimum 2 points must be required, that is a 0 comma 50, b 50 comma 0. On the other hand, solve this. Now for this, put same procedure, put x is equal to 0. If we put x is equal to 0, then 0 plus y is equal to 90, y is equal to 90, therefore the point c is equal to 0 comma 90. Again put y is equal to 0. If you put y is equal to 3x plus 0 is equal to 90, 3x is equal to 90, x is equal to 90 divided by 3 is 30. The other point d is equal to 30 comma 0. That's all. So these are the 4 points A, B, C, D. Using this, just represent these points in a graph. That's it. Now to draw the graph, right, let us take a suitable scale. Scale on x and y axis, on x axis and y axis, 1 centimeter, 1 unit is equal to 10. So 1 centimeter, that is 1 unit is equal to 10. Now this is 10, 20, 30, 40, 50, 60, 10, 20, 30, 40, 50, 60. Now let us take the first point. What are the points we have? A is 0 comma 50, B 50 comma 0, C is 0 comma 90 and D 30 comma 0. These are the points. Let us represent here. First A, x is equal to 0, y is equal to 50. This is A 0 comma 50. B 50 comma 0. This is 50 comma 0. B. So B, this is the point B, 50 comma 0. Just draw a straight line like this. Draw a line. This is the line. So here, what is this equation? This is nothing but first equation. What is the first equation? That is x plus y is less than or equal to 50. So if you put x is equal to 0, y is equal to 0, 0 plus 0 is 0, which is less than 50. So that means the feasible region is towards the origin. So the feasible region is going in the downwards direction, that is in the downwards direction, that is towards the origin. Right, this is the feasible region. Now for the second curve, what are the points? C is equal to 0 comma 90, x is equal to 0, y is equal to 90. So this is the point C, 0 comma 90. And for D, 30 comma 0, this is 30 comma 0. What is the equation? The second equation is 3x plus y is less than or equal to 90. Again, if you put x is equal to 0, y is equal to 0 plus 0, which is less than 90 is true. So which is true? 0 is less than or equal to 90 is true. So the feasible region is towards the origin. Again, so the feasible region towards the origin for the two curves is, this is the feasible region. So this is the shaded region will give the feasible region. Now just find out the point of contact. So here 0 comma 0 and A 0 comma 50 and this point, that is a point D 30 comma 0, and just draw these lines. So this will cut the x axis at 20 and y axis at 20. So therefore, the point of intersection E is equal to 20, 30. So the point of intersection for both the curves is E. So that means this will curve the x-axis at 20 and y-axis at 30. So these are called as the corner points. So therefore, the corner points are the corner points. Here the corner points, I will write the corner points. What are the corner points? 0, comma, that is O, A, E and D. E and D, these are the corner points. Now the corner points are O, 0, 0, A. What is A? A is equal to 0, 50 and E. What is E? E is equal to 20, 30 and D. What is D? D is equal to, this is D, 30, 0. Now let us represent this. Now corner points and what is the objective function? The function is z is equal to 4x plus y. Z is equal to 4x plus y. Substitute here. That's it. So at O 0, 0, this is 0. Next at the first point A 0, 50. So here 4 into 0 plus y is 50, that's equal to 50. Next second at E, what is E? 20, 30. 20, 30. This is 4 into 20 plus 30. 4 into 20 is nothing but 80 plus 30 is equal to 110. And the last point, what is the last point we have? That is D. At D, what is D? D is 30, 0. So this is Z 30, 4 into 30 plus 0, 4 3s are 12, 120. Now what is to find? The objective function is the max Z, maximum of Z, maximum of Z. What is the maximum value in this table? 120 is the maximum value. This is maximum. So here the maximum value is 120. This is the maximum value. Maximum is 120. So therefore, Z maximum is equal to 120 at, what are the point? 30, 0. This is how we are going to solve a linear programming problem by graphical method. Hope you followed. Okay. Right. Now move on to the next type problem. Solve the following linear programming problem graphically. Maximize Z. This is also maximization of Z. Z is equal to 200x plus 500y subjected to constraints. X plus y is greater than or equal to 10 and 3x plus 4y is less than or equal to 4 and x and y greater than or equal to 0. Now just let us convert. Now just convert the inequalities into equalities first. What are the equation given? X plus 2y is greater than or equal to 10 can be written as x plus y is equal to 10, and the second equation 3x plus 4y is equal to 24. Now if you put x is equal to 0, put x is equal to 0, you will get 2y is equal to 10, y is equal to 10 by 2 means 5. Therefore the first point A is equal to 0, 5. Now put y is equal to 0. If you put y is equal to 0, x is equal to 10. Therefore the point B is equal to 10, 0. Right. Now put x is equal to 0. 4y is equal to 24. Y is equal to 24 by 4. That is nothing but 6. 6 4s are 24. So therefore the point C is equal to x is 0, y is 6. Again put y is equal to 0. If you put y is equal to 0, what happens? 3x is equal to 24. X is equal to 24 by 3. That is nothing but 8. So therefore the point D is equal to x is 8, y is 0. Okay, these are the points. Now let us represent this on a graph. So what is for the first curve? Yes, let me draw the lines here. xy, xy. This is for the first curve. For the first curve, x plus 2y is greater than or equal to x plus 2y is greater than or equal to 10. Another one is 3x plus 4y. 3x plus 4y less than or equal to 24. So when x is equal to 0, x is equal to 0, y is 5. When x is equal to 10, y is 0. So this is 0 comma 5 and 10 comma 0. Again, when x is 0, y is 0. When x is 0, y is 6. When y is 0, x is 8. The points are 0 comma 6 and 8 comma 0. Right, these are the points. Let us represent this on a graph. Right. Now, let us take first point. A 0 comma 5. When x is equal to 0, y is equal to 5. This is the point 0 comma 5. A 0 comma 5. Next, B. When x is 10, when x is 10, y is equal to 0. X is 10. X is 10. When x is equal to 10, y is equal to 0. This is the point B. So the scale as usual, 1 centimeter scale, 1 unit is equal to 1 centimeter on both x-axis and y-axis. On x and y-axis, the scale is 1 centimeter is equal to 1 unit. Now, just draw this line. So that is, draw this. This is the straight line. So that is x plus 2y. X plus 2y is greater than or equal to 0. Greater than or equal to 0 means the feasible region is above the origin. The feasible region is going away from the origin. Right. Next, second curve. When x is equal to 0, y is equal to 6. This is point C, 0 comma 6. When x is equal to 8, 1, 2, 3, 4, 8 and y is equal to 0, this is D. Now draw this line. So if you draw, so you are going to get a line like this. Right, this is the curve. What is the curve? 3x plus 4y is less than or equal to 24. Less than or equal to 24 means, since less than or equal to means it is going in the downwards direction, that is in the downwards. So here this is the feasible region, that is A, C and now just find out the value of this. So definitely you will get x is equal to 4 and y is equal to 3. This is the point of intersection. So therefore the corner points are B 4 comma 3 and A 0 comma 5 and C 0 comma 6. So this is nothing but the area, that is the shaded region, is the feasible region for this curve. Now, so the corner points are, therefore the corner points are A, C and B. Now, therefore, the corner points are A 0 comma 5, then 0 comma 6 and 4 comma 3. Call it as E. Already we have taken A, B, C, D. Call it as E. This is, sorry. Call it as E. This is E. Now, what are the corner points? The corner points and the objective function z is equal to, what is the objective function? Z 200x plus 500y. 200x plus 500y. Substitute here at the first point at A 0 comma 5, at A 0 comma 5. So this is 200 into 0 plus 500 into 5. So this is 0, 500 into 5 is 2500. Next, for the second at second point, what is the second point? That is C 0 comma 6. For 0 comma 6, this is 0 plus 500 into 6. 5 6 are 30, that is 3000. Again for the last point, that is E, at E. What is E? 4 comma 3. 4 comma 3, we will get 200 into 4 plus 500 into 3. 2 4s are 8, 800 plus 5 3s are 15. What is this equal to? 15 plus 800 is 2300. Right. Now what is the objective function? Objective function is maximization. So maximum value means, what is the maximum value from the table? Here the maximum value is 3000. If it is minimum means 2300 is the minimum value. This is the minimum value. So just they asked to find the maximum. Z maximum is equal to 3000 at 0, 6. Suppose if you want to find minimum, Z minimum value, what is the minimum value? 2300. 2300 at, what are the points? 4, 3. At 4, 3, this is minimum. That's it. Okay. So this is how we are going to solve this problem. Now let us take one more problem. Solve the following linear programming problem graphically. Minimize and maximize. Here both the conditions are given. Minimize and maximize. Z is equal to 3x plus 9y. Subjected to constraints x plus 3y less than or equal to 60, x plus y greater than or equal to 10, and one more curve is there, x is less than or equal to y, x is greater than 0 and y is greater than or equal to 0. Now just let us convert these inequalities into equalities. X plus 3y is equal to 60. Again x plus y is equal to 10, and one more curve, x is equal to y. Now if you put x is equal to 0, 3y is equal to 60, y is equal to 60 by 3, that is nothing but 20. So therefore the first point A is equal to 0, 20. Now put y is equal to 0, then what you will get? X is equal to 60, the point B is equal to 60, 0. Right. Now again just move on to the next curve. X plus y is equal to 10, put x is equal to 0, y is equal to 10, therefore 0, 10. Put y is equal to 0, x plus 0 is equal to 10, x is equal to 10, therefore the point D is equal to 10, 0. Now here since x is equal to y means you can take any value 5, 5. So if x is equal to 5, y is also equal to 5. One point is 5, 5. Other point 10, 10. 15, 15. Or 20, 20. Any points you can take. Now let us represent these points on the graph. Now let us take 1 centimeter is equal to 5 units. 5, 10, 15, 20, 25, 30. 5, 10, 15, 20, 25, 30 like this. Now what is the first point? So A that is 0, 20 and 60, 10. 0, x is equal to 0, y is equal to 20. Let us represent this as 0, 20. So A 0, 20. And then second point, what is the second point? B 60, 0. 60, 0. This is B 60, 0. Just draw a line like this. Okay. So this is nothing but, what is the first line? X plus 3y is less than or equal to 60. Less than or equal to 60 means this is towards the downwards direction. Right. Next, second curve. What is the second curve? X 0, 10 and 10, 0. X is equal to 0, y is equal to 10 and 10, 0. So this is the point C and D. So just draw a line like this. What is the curve here? X plus y. X plus y is greater than or equal to 10. Greater than or equal to 10 means it is above the origin, moving upwards direction. Now the very important curve is this. When x is equal to y means when x is equal to 5, y is also equal to 5. When x is y, y is 5. Let us represent this as B. For E or anything, A, B, C, D, we have already taken, we can call it as E. Again, 10, 10, this is 10, 10, 15, 15 means x is equal to 15, y is equal to 15. Now, so since here what is the condition given? X is less than or equal to y. So x is less than or, since this x is less than or equal to y, therefore the feasible region is towards the y axis. So this is the feasible region, solution region. Now, therefore, the corner points are, these are the corner points. First one is 0, 10, 0, 10, 0, 20, then 15, 15, and the last one is 5, 5. So, these are the corner. You can name A, B, C, anything you can represent for this. 0, 10, 0, 20, 15, 15, 5. So, these are called the corner points. That is, this 0, 10, 5, 5, 15, 15 and 0, 20. Now, let us find out the optimal solution for this. Now, here, what is the objective function? Z is equal to 3x plus 9y. Z is equal to 3x plus 9y. Right, at Z is equal to 3x plus 9y. Now, at first point, what are the points? 0, 10. 0, 10. So, this is nothing but 3 into 0 plus 9 into 10, that's equal to 90. Next, at second point, 0, 20. 0, 20. This is 3 into 0 plus 9 into 20. 9 into 20, 20 into 9 is 180. Next, 180. 180. So, the next point is 5, 5 and 15, 15. So, 3 into 5 plus 9 into 5. What is this equal to? That's 5 3s are 15 plus 45. That's equal to 60. And the last one is 3 into 15 plus 9 into 15. That is 45 plus 135. That's equal to 180. Now, what is the maximum and minimum value? So, you can observe carefully. So, there are two maximum values. This is maximum, this is also maximum. So, there are two maximum values. These are two maximum. What is the minimum value? Minimum value is 60. So, this is the minimum value. That means, therefore, Z minimum is equal to, Z minimum is 60 at 5, 5. And Z maximum is equal to, the maximum value is 180 at, what are the points? 0, 20 and another value 15, 15. So, therefore, the function is minimum at 5, 5, minimum value is 60 and maximum at 0, 20 and 15, 15, the maximum value is 180, 180. 180 is the maximum, 60 is the minimum. That's it. Hope you followed, right? So, this is how we are going to solve the problems based on a linear programming method by graphical method. So, definitely we will expect one question from this for 6 marks and one objective type question like the definitions. Hope you followed. That's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.